Hello bachcho, let's read this question. So the question says, an orbital is designated by certain values of first three quantum numbers n, l and m, and according to Pauli's exclusion principle, no two electrons in an atom can have all the four quantum numbers equal. So n, l and m denote size, shape and orientation of the orbital. The permissible values of n are 1, 2, 3 up to infinity, while that of l are all possible integral values from 0 to n minus 1. Orbitals with same values of n and l but different values of m, where m can have any integral values from -l to +l including 0, are of equal energy and are called degenerate orbitals. However, degeneracy is destroyed in an inhomogeneous external magnetic field due to different extent of interactions between the applied field and the internal electronic magnet of different orbitals differing in orientations. So for L is equal to 0, 1, 2, 3, the states or subshells are denoted by the symbols S, P, D, F respectively. L determines the orbital angular momentum, that is capital L of electron, as L is equal to small l multiplied by L plus 1 square root over h by 2 pi. On the other hand, M determines Z component of orbital angular momentum as Lz is equal to m multiplied by h over 2 pi. Hund's rule states that in degenerate orbitals, electrons do not pair up unless and until each such orbital has got one electron with parallel spins. Besides orbital motion, an electron also possesses spin motion. Spin may be clockwise and anti-clockwise. Both these spin motions are called two spin states of electron and characterized by spin quantum number s is equal to plus half and minus half respectively. The sum of spin quantum number of all the electrons is called total spin, and 2s plus 1 is called spin multiplicity of the configuration as a whole. The spin angular momentum of an atom is written as Ls is equal to s multiplied by s plus 1 square root multiplied by h over 2 pi, where s is equal to sum of spin quantum number of all the electrons. Another term, magnetic moment mu, is defined as mu in Bohr magnetism is equal to n multiplied by n plus 2 square root, where n is the number of unpaired electrons. So the question is, what is the spin angular momentum of nitrogen atom? Atomic number is equal to 7, where electronic configuration is 1s2, 2s2, 2p3 in ground state. So let us solve this question, and here the key concept is quantum mechanical model of atom. ऑलराइट, सो यहाँ पर देखते हैं. फर्स्ट ऑफ ऑल हमें नाइट्रोजन की इलेक्ट्रॉनिक कन्फिगरेशन लिखनी है. दैट इज नाइट्रोजन 7 इज 1s2, 2s2, 2p3. सो 2p3 को हम अगर एक्सपैंड करके लिखें, देन दिस इज 2px, 2py एंड 2pz. और अकॉर्डिंग टू हर्ट्ज रूल, हर एक ऑर्बिटल में एक एक इलेक्ट्रॉन फिल होगा बिफोर पेयरिंग. सो हियर we have one electron, here we have one electron, and here we have one electron. Now if we have to show this diagrammatically, then ये 1s ऑर्बिटल है, ये 2s ऑर्बिटल है, और ये 2p सबशेल है जिसमें कि 2p के ऑर्बिटल्स प्रेजेंट है, 2px, 2py एंड 2pz. सो 1s में दो इलेक्ट्रॉन्स प्रेजेंट है. सो फर्स्ट दिस इज वन इलेक्ट्रॉन with a positive spin, or second this is another electron with negative spin. So this has plus half and minus half. Then 2s में भी दो electrons present है, one is this one, another is this one. So plus half and this is minus half. Now 2px में तीनों जो electrons है वो same spin में present है. So let us put them as plus half and plus half. So this is plus 1 by 2, plus 1 by 2 and plus 1 by 2. So we have to determine the total spin quantum number, that is s. So s की वैल्यू कितनी हो जाएगी? प्लस हाफ प्लस माइनस हाफ प्लस यहाँ पर अगेन प्लस हाफ प्लस माइनस हाफ प्लस यहाँ पर 3 इंटू प्लस हाफ. ऑलराइट, सो यहाँ पर प्लस हाफ और माइनस हाफ कैंसिल हो गए एक दूसरे से, एंड वी हैव 3 मल्टीप्लाइड बाय 1 by 2, दैट इज 3/2. Alright, so spin angular momentum का फॉर्मूला ये है, that is ls is equal to s multiplied by s plus 1 square root multiplied by h over 2 pi. So यहाँ पर s की वैल्यू 3/2 है, 3/2 multiplied by 3/2 plus 1, इसका स्क्वायर रूट multiplied by h over 2 pi. So 3/2 multiplied by 5/2, 5/2 square root multiplied by h over 2 pi. So this value ls is equal to 15/4 square root multiplied by h over 2 pi. So this is the spin angular momentum of nitrogen atom, and the correct option is option number C. This is the required answer, and I hope you understood the concept well. Best of luck.